You are about to learn how to graph parabolas that are given to you in standard form. And you might even be able to look at a graph and tell what the standard form might look at in this process as well. So first we're going to take a look at the parts of the parabola. We're going to take a look at axis of symmetry, vertex, the different types of intercepts. Now we're going to take a look at the parts of the parabola. First up, we have the axis of symmetry, which is the line where the parabola can be split in half. It is represented by the equation x equals h, where h is the x-coordinate of the vertex. Now, as you can see in our graph, the axis of symmetry is that orange dotted line that seems to split this parabola in two. And it goes through that green point, the vertex, at the bottom there. And for this particular problem, you'll see that the axis of symmetry is at x equals 1. The vertex is the maximum or minimum point of the function. This is a point usually represented as hk. For this particular example, the vertex will be considered to be 1, -4. The y-intercept is the point at which the graph crosses the y-axis, usually represented as 0y. In this example, it's this purple point right here. That is the point 0, -3. The x-intercepts is where the graph crosses the x-axis, usually represented in the form some x value, 0, and then another x value, 0. In this example, we have two x-intercepts, one at -1, 0, and the other one at 1, 2, 3, 0. 1, 2, 3, 3, 0. So we have -1, 0 and 3, 0. Up or down, wide or narrow. There's one number that controls all of these things, and that is a. The a in the equation of a parabola in standard form determines whether the parabola will open up or down, and it also affects the width of the graph. If it's a positive number, then it's going to open up. If it's a negative number, then it's going to open down. If a is a big number, meaning a is more than 1, you're going to have a vertical stretch, which is going to make it appear to be more narrow than regular y equals x squared. If a is less than 1, then it's going to appear to be wider. It's really a vertical compression, but it's going to appear to be wider than y equals x squared. Now, the reason why I put those funny looking lines on there, it's absolute value, meaning I'm not talking about whether a is positive or negative. I'm just talking about if the actual number is more than 1 or less than 1. The positive and negative only affects whether it's opening up or down. Where does it cross the y-axis? Well, we're going to dive a little bit deeper into this, but for now, we're just going to say 0C. Finding vertex from standard form. When trying to find the vertex of a parabola in the form y equals ax squared plus bx plus c, we're going to use a very simple formula. We're going to use the equation x equals -b/2a just to find the x-coordinate. So when I say -b/2a, we're using the number that's in front of the regular x term, and we're using a, which is the number before the x squared. If there's no number there in front of the x squared, then a is going to be 1. If there's no number in front of the x, then b is going to be 1. If there is no middle term or no x term right here in the middle at all, if that entire thing is missing, then b is going to be 0. So you're going to plug that number that you find from the formula, x equals negative b over 2a, back in place for x in the original equation to find the y coordinate. So if you remember about functions, x's are your inputs and y's are your outputs. So it makes sense that if I found the input for my vertex, I just need to plug it back in the equation to get the output for my vertex. Finding axis of symmetry from standard form. We're going to use the same process, the exact same process. Since the axis of symmetry is simply the coordinate of the vertex, it's even less steps. All you need to do is use the equation x equals negative b over 2a, and that will give you your answer. Because the axis of symmetry is an equation, you're just going to leave the x equals there and put the number there, and that's it. Alright, so now we're going to find intercepts from the standard form. And when I'm saying standard form, I'm talking about y equals ax squared plus bx plus c. So when we're trying to find the x-intercepts of a parabola in this form, the first step we need to do is factor. If you want to review over factoring, you can check out the other videos. We're going to make each factor equal 0. And then step 3, you're going to solve for x for each factor. Now we'll give some examples of that a little bit later. When trying to find the y-intercept in any form, you're going to end up replacing every x with 0. And then you just need to simplify. What this means is that when I plug in 0 for x, I'm going to end up with a times 0 squared plus b times 0 plus c. So what ends up happening is this becomes 0 and this becomes 0, and I end up with y equals c. So when trying to find the y-intercept of a parabola in the form y equals ax squared plus bx plus c, all I need to do is put 0 and then whatever c is. It's a point, so it's just 0c.